So now let's talk a little bit about the actual processor inside the Raspberry Pi, just a bit. So it's an ARM-based processor. So what does that mean? So the processor is a Broadcom chip, right? A Broadcom SoC, but it's an ARM-based processor. So ARM processors, ARM is a company, British company, and they license intellectual property. So what that means is they don't actually fabricate these chips. What they do is they design the chip, or they design the core of the chip, the processor core, right? So they design the processor, and then they license the design to a company. So they don't fabricate it, they don't build a chip, they sell it to, they say, okay, Freescale, for instance, you can pay us this money, you can fabricate a number of these chips. So they give the design to the processor to, say, Freescale or TI or whatever company it is that's licensing, and then that company builds a system around it. So that's the picture that we have here on the right is not our particular processor. It's just sort of a generic SoC, generic system on chip. Now, you can see that there's a processor up there. One of the blocks says processor, right, along the top. That block, that would be the ARM processor core that is licensed from ARM. So, but then around that, the company who licenses it, in our case Broadcom, would say, okay, in addition to this processor, we need some debug logic, we need some flash memory, we need some SRAM. They take all these other components that they design, either they design them themselves or they license them from other companies, or ARM itself, right? They can license all these components or build them themselves, but they build this whole system around the processor. So there is a processor licensed by ARM, and then there are a bunch of other components that Broadcom decides to put together. And they put them together on a couple of buses and so on, and then they make a chip out of it, and they fabricate that, and they sell it as their part. So even though it's a Broadcom chip, it's a Broadcom SoC, it's actually an ARM processor core inside it. And what that means is that defines the instruction set that's used. So these processors, the machine code instructions that are used are ARM machine code instructions because at its heart, it's an ARM processor. So ARM licenses the intellectual property, and just so you know, ARM licenses most embedded processes, most processes that you find in an IoT device of any kind, like my cell phone, for instance, like this camera in front of me. All these different devices, almost all of them have ARM processors, ARM cores inside. Okay, so ARM just dominates that market pretty well, not completely, but pretty well. So. Silicon vendors like Broadcom or Freescale or whoever build this system on chip design based on the ARM IP standing for intellectual property. Over 15 silicon vendors use ARM, and they dominate. And ours is a Broadcom BCM 2836 SoC based on an ARM Cortex-A7 processor core. So ARM Cortex-A7 is the name, the processor core that ARM sells, or one of the many processor cores that ARM sells. So let's take a glance at this ARM processor family. ARM sells a lot of processor cores. And this is ARM's marketing material, and they're trying to plot all the different processors that they sell. Now, if we look at it, on the left side, in the blue, they have what are called the classic processors. So that's ARM 7, ARM 9, ARM 11. Though classic means old, okay? So they're old processors. Now they still support these because there are so many out there in the wild, right? Because there's so many products that still have those. But newer products, those parts are, I don't even know if they license that out new to anybody, probably not. But they certainly support those. So those are the classic ones. But on the right, the Cortex processors are all their newer ones. So you see the Cortex processors, actually you can see that they go from bottom to top. Roughly what bottom to top means in this chart is it refers to power performance, not just power, I shouldn't say power because it's not, actually it does relate somewhat to power consumption, but it's performance and ability, features, the amount of features that it has. So the processor at the bottom, take that green one, that Cortex M0, okay? That thing is their low end processor core and has the fewest features, it's the slowest, and so on. Where you scale all the way up to that Cortex A15. In fact, they might even be up to, I think they might have an A17, I can't remember. But anyway, that's high end. That type of processor would be used in laptops and desktops or tablets or something like that, right? And it's faster, it has lots of memory, lots of stuff on it. So they have this sliding scale, and they categorize those into embedded and application, right? The green ones are embedded, those orangey, yellow-looking ones are application. But really, I see them, there's a sliding scale. So there's not a hard difference between what they're calling embedded and what they're calling application. It's just they're getting more and more capability as you go up. Now, the one that our Broadcom processor that the Raspberry Pi uses is the Cortex A7. So I've highlighted that, circled it in red there. The Cortex A7 is the one that our processor is based on, which is pretty good. Thank you.